Hi, we'll be solving remainders problem today. What is the remainder when 2 raised to 92 is divided by 7? So we need to find the remainder of 2 raised to 92 when it is divided by 7. Let's solve the problem using two methods. In the first method, we are going to use the concept of cyclicity of remainder of power of 2 when it is divided by 7. So if we do that, remainder of 2 raised to 1 by 7 will be equal to 2. Remainder of 2 square by 7 is same as remainder of 4 by 7 and will be equal to 4. Remainder of 2 cube by 7 is equal to remainder of 8 by 7 and will be equal to 1. Now since we got a 1, so there's a good chance that the cycle will repeat. So if we try 2 raised to 4 by 7, remainder is same as remainder of 16 by 7 and will be equal to 2. We can go on. So remainder of 2 raised to 5, which is 32 by 7, will be same as 4. So we see there is a cycle of 3. That means we will divide 92 by 3 and check the remainder. Since the remainder is 2, that means 2 raised to 92 by 7 will give the same remainder as 2 square by 7 and will be equal to 4. So answer will be option number D. Now let's try the problem using another method, which is called as binomial theorem. Now in the concept of binomial theorem, whenever we have a big number like this and we are dividing it by, let's say, a number 7, then the idea is to express this number into two terms such that one term will be a multiple of 7 and other term will be a very small number. So if we notice 2 cube is actually equal to 8, which can be written as 7 plus 1. So in order to achieve that, we will break 2 raised to 92 as 2 raised to 90 multiplied by 2 square. So this becomes 2 cube whole raised to 30 multiplied by 4. That means remainder of 2 raised to 92 by 7 is same as remainder of this term by 7 multiplied by remainder of 4 by 7. Now remainder of 4 by 7 is 4. So we just need to focus on this. So this term is 8 raised to 30 divided by 7, which can be written as 7 plus 1 whole raised to 30 divided by 7. Now we'll be using the concept of binomial theorem to expand this expression. In order to do that, we will write the terms where each term will have a combination whose top will start with 30, bottom will start with 0, power of 7 will start with 30, and power of 1 will start with 0. Plus the next term will be 30C1, power of 7 will decrease, so 7 raised to 29, power of 1 will start increasing. This will go on, and second last term will be 30C29, 7 raised to 1, 1 raised to 29, and last term will be 30C30, 7 raised to 0, and 1 raised to 30. Now if we see, all the terms have a power of 7. Right? Except the last term, which has 7 raised to 0. That means remainder of all the term except the last term when divided by 7 will be equal to 0. And the problem is reduced to what is the remainder when the last term, which is 30C30, 7 raised to 0, 1 raised to 30 is divided by 7. Now we know 30C30 is equal to 1, 7 raised to 0 is also equal to 1, and 1 raised to 30 is also equal to 1. That means what is the remainder when 1 is divided by 7? So that means remainder of this term is 1 and we had a remainder of 4 here. So our overall remainder becomes 4. So answer will be option number D. Now in the concept of binomial theorem, you don't really have to write all the terms. You can just write the last term. In fact, in the last term also, you can just write this second term raised to this power and take this sign also. So you just need to write. So if this is the expression you're expanding, then you just need to convert this to 1 raised to 30 divided by 7, right? So it is as simple as that. You don't have to focus on all the terms before that. Now, if you want to master the concepts of remainders, do check out the theory video and the solved problems provided in the description of this video, where I teach you those concepts from scratch. Hope you found the video useful and do share your comments on the video. Thank you.